Okay, Assalamualaikum and hello everyone. How's your head? How's your head, guys? Okay, so today, for this week, we will try to cover 4.3, and if we're lucky, we'll cover 4.4 and 4.5 because I'm crazy like that. We have to cover before EPS, guys. So let's head on to new subtopic: orbital overlap and hybridization. Okay, so the learning objectives for this video, we will learn how to draw and describe the formation of sigma and pi bonds from overlapping of orbitals. So the rest will be covered later. So, before that. So we learned VSEPR theory, and VSEPR theory helped us in predicting the molecular shapes. But it does not tell you how bonding occurs. So we're going to use valence bond theory. So valence bond theory, it explains the formation of covalent bonds and the molecular shape that you predicted using VSEPR theory. Okay? And the theory states that a covalent bond is formed when the neighboring atomic orbitals overlap. So, if you have from Lewis symbol, for example, for the formation of hydrogen molecule, we will draw the number of valence electrons for hydrogen, and then we get the Lewis structure for hydrogen molecule like that. But we don't know the details of this bonding. Okay, so if we use valence bond theory, we will get to see which electrons in which orbital will interact with each other. Okay, not just like this. Okay, so how do orbitals overlap? So orbitals will overlap between orbitals overlapping may occur between orbitals with unpaired electrons, and second, an orbital with paired electrons and another with empty orbitals. So that's your dative bond. But we will focus on the first one, the orbitals with unpaired electrons. So in this diagram, this slide, we'll see how a hydrogen molecule is formed. Here we have the 1s orbital of hydrogen atom. So this is 1s orbital and this is 1s orbital of the hydrogen atom. So each 1s orbital has one unpaired electron. Okay. So to form a covalent bond in your hydrogen molecule, the orbitals will come closer to each other in order to overlap. So when they overlap, there's a change in electron density, how your electrons are distributed. Okay. So, in this last picture here, your two orbitals and your unpaired electrons, your orbitals have overlapped and your two unpaired electrons have paired up with each other. So, that's why you see a high electron density in the middle of this molecule. So, between the two atoms, you have two electrons being shared. Okay, so that is a brief explanation of valence bond theory. So now we're going to see the types of covalent bond that we can have. There are two. So the first one is sigma bond. Sigma bond denoted by this symbol, sigma. And second, you have pi bond. Pi bond denoted with pi symbol. Alright. So the sigma bond is formed by end-to-end overlapping of orbitals. So end-to-end maksudnya hujung ke hujung. Overlapping bertindan ikut. So you are going to overlap end-to-end your orbitals. So the electron density is concentrated between the nuclei of the bonding atoms, and all single bonds are sigma bonds. Okay. Next, we're going to look at how we will form the sigma bonds. So firstly, you can form sigma bond by overlapping of s orbitals. So here we have two s orbitals. So each s orbital has one unpaired electron. So when you overlap these two orbitals, you will get this picture of your overlap. So when you overlap n to n, your orbitals, your s orbitals, your electrons will be paired up, and this n to n overlap results in a sigma bond. Okay. So s orbital will always form a sigma bond because it is spherical in shape. Okay. It cannot overlap sideways. It is spherical, so memang n to n saja. Okay. Next way, you can form sigma bond by overlapping s and p orbitals. Okay, so when you overlap your s and p orbitals, n to n, hujung ke hujung, you will get a sigma bond here. So this is the n to n overlap, okay? N to n, hujung of this p orbital. Okay. Finally, you can also form sigma bond by overlapping p orbitals. So you have two p orbitals. So these p orbitals should be in the same orientation. Contoh, it should be px, px, py, py, pz, pz. So in this case, let's say this is px. So it will be at the x-axis. I mean px lah kan. So your p orbital is along the x-axis. And when you overlap them, n to n, you will have a sigma bond here. Okay? So pi bond is formed when two p orbitals of the same orientation overlap sideways. Okay, sideways ni. Okay? Sideways and same orientation. Maksudnya px plus px saja, py plus py, pz and pz. Why Do you know why? It's because this is the most efficient overlap, okay? Lowest energy, most efficient overlap of orbitals. So in pi bond, the electron density is concentrated above and below the plane of the nuclei of the bonding atoms. So here you have your two p orbitals, 1, 2. So when you overlap them sideways, this is how it looks like. This is sideways overlap, okay? So this middle part here, this overlap will form the pi covalent bond. And when, apa maksud dia with electron density is concentrated above and below the plane of nuclei, it means that macam ni. Okay, above and below the plane. So macam it looks like this. Above and below the plane. Ni plane, okay? So that's your pi bond. So now we're going to look at the covalent bonds that can form in your molecule. It can be between pure orbitals and between hybrid orbitals and between pure and hybrid orbitals. So first we're going to look at the pure orbitals. Okay, your pure orbitals will be S, P and D orbitals. But usually we'll see S and P orbitals because they are the ones that are involved in your valence electrons are usually in those orbitals. So note that if you have multiple bond, you will have pi bond. Okay, so if you have double bond like this, then one of the bond must be a sigma bond, the other will be the pi bond. Okay, if you have a triple bond like in carbon monoxide, the one of the bonds will be sigma bond and the other two will be pi bonds. So in triple bonds, you will have 1 sigma bond and 2 pi bonds. Okay, remember this because this is important when we are going to draw our overlap of orbitals later. So I'm going to show for hydrogen first. So the first step that we should do is for the formation of bonds in hydrogen molecule, we will start with the Lewis structure of hydrogen molecule. So the Lewis structure for hydrogen molecule is like this. Okay. Now from the Lewis structure, you can tell that you have 1 sigma bond. 1 sigma bond. So we will form 1 sigma bond. Okay. Next, you're going to draw the valence orbital diagram. Okay. Why? Because we want to see which electron in which orbital are going to interact. Okay, in the formation of your sigma bond. So for hydrogen in ground state, it is in ground state because hydrogen in ground state maksudnya it as atom lah. So you will have 1s. So 1 unpaired electron. Okay. So in each 1s orbital, you have 1 unpaired electron. So each 1s orbital consists of 1 unpaired electron. So the 1s orbital of each atom, of each hydrogen atom, will overlap with the 1s orbital of the other hydrogen atom. To do what? To form 1 sigma bond. Okay? So, this is your explanation for using valence bond theory. Okay? So 1s orbital contains 1 unpaired electron. So the 1s orbital of hydrogen atom will overlap with the other 1s orbital of the other hydrogen atom to form 1 sigma bond. Okay, now we're going to draw the orbital overlap. How will it look like? So first you're going to draw your 1s orbital of your first hydrogen atom. 1s hydrogen, and you have 1 unpaired electron. 1 unpaired electron. So and then you're going to draw the other one. Lukislah cantik-cantik saya ni macam Okay. And then you're going to overlap these two s orbitals. So you're going to show your overlap. So make sure to label the name of your orbital and your atom. And then, now that you have overlapped your orbitals, that means your electrons will be paired. Okay, since you overlap 2 s orbitals end to end, you will get a sigma bond, right? So that's the explanation for your hydrogen molecule. So your hydrogen molecule is a linear shape, right? So in this orbital overlap, you can tell that your molecule is in linear shape, and you can see which electrons in which orbital is involved in the bonding in your hydrogen molecule, right? Okay, so next you're going for HF. I will show you as well. First, you're going to draw the Lewis structure. So, semua orang dah tahu nak lukis Lewis structure? Okay. So, that's the Lewis structure. So, from there, you can tell that you will form 1 sigma bond. Right. And then, you're going to draw the valence orbital diagram. for hydrogen at ground state. So hydrogen in 1s orbital, you have one unpaired electron, right? Because the valence electron is 1. Fluorine at ground state, it will be 2 2 kan? I think so. So 7 electrons, 1, 2, 3, 4, 5, 6, 7. Okay. From here, we can see that each 1s orbital of your hydrogen has one unpaired electron. And your fluorine atom has one unpaired electron in the 2p orbital. Therefore, the 1s orbital of hydrogen will overlap with the 2p orbital of fluorine atom, so that these two electrons will be paired up, okay, to form one sigma bond. So that's the explanation. Sila tulis, saya tak tulis. So now I'm going to show the orbital overlap. So you're going to draw your 1s orbital for hydrogen, one unpaired electron, and then your 2p orbital, of your fluorine atom. You will have one unpaired electron. So you're just going to draw the unpaired electrons, okay? And then you're going to overlap them. Show the overlap. Okay. So fluorine, hydrogen, 1s, 2p. So now your electrons are paired. So from this end-to-end overlap between s and p orbital, you get a sigma bond. Okay? Okay. So, ni buat sendiri. Taklah, saya buat yang ni. Okay lah, nitrogen lah. Okay, so for nitrogen, you're going to draw the Lewis structure. Okay. And then, you will write down how many sigma, how many pi's you're going to form. So you're going to form one sigma bond. And you're going to form 2 pi bonds, right? Two pi bonds. Sorry, tukar lagu. Okay. Then you're going to do the valence orbital diagram for nitrogen at ground state. So nitrogen is in group 15 and is in period 2. So you're going to have 5, 1, 2, 3, 4, 5 valence electron at nitrogen ground state. So from here, you can see that we're going to form one sigma bond, so 2 pi bonds. That means you're going to need one unpaired electron and 2 unpaired electrons. That means you need 3 unpaired electrons. 3 unpaired electrons from each nitrogen. Okay, so here you can see 3 unpaired electrons. Okay, so the first unpaired electron, you're going to form sigma bond. Second, the other 2 will be for forming pi bond. Alright, so that means each in each 2p orbital, 1, 2, 3, you have one unpaired electron, right, in your nitrogen. So that means one unpaired electron will form one sigma bond, and the other 2 unpaired electrons will form the 2 pi bonds. Okay, so now orbital overlap. Okay, First, you're going to, untuk senang, start with forming the sigma bond. Okay. So 2p orbital kan? So you will overlap them sideways. 1, 2. Okay. So ini 2p orbital, 2p orbital, nitrogen, and then your electrons are paired and you get a sigma bond. Okay, now I'm gonna change my color. So we're going to next form the pi bond using this unpaired electron. So pi bond you will overlap sideways. So kisah macam tu. Your 2p orbitals. And you have one unpaired electron in each of the 2p orbital. So you show your formation of pi bond like this. Okay. Okay. So dah. Same orientation. Okay. Next. I'm gonna color hijau. Okay. The last p orbital. 2p orbital. Okay. Pi bond kan? So you will overlap them. You get another pi bond. Okay. Can you see? Can you see how the orbitals overlap? So now, your nitrogen molecule, you know that it is linear, right? So this shows that it is also linear, and you have 3 bonds. Those 3 bonds are your sigma bond, your 2 pi bonds. And you can see which electrons from which orbital are involved in the formation of your covalent bonds, right? Okay, right. So that's N2. So we're going to summarize. So valence bond theory explains the formation of covalent bond by the overlap of neighboring atomic orbitals. So the sigma bond is formed by n to n overlapping of orbitals. So all sigma bonds are all single bonds are sigma bonds. Pi bond is formed when 2p orbitals of the same orientation. Okay, same orientation, overlap sideways. Alright. So that's the take-home messages for this video. I'll see you later in the next video. Okay, bye.